Well, welcome. My name is Mr. Murphy, and in this lesson we're going to be looking at the last lesson for this first unit. And this lesson is all about how to solve linear systems. So we're going to start in this first part of the lesson. We're going to be looking at how to solve a system of equations and the system of linear equations. And then in the second lesson you're going to be learning how to solve a system of linear inequalities. So let's go ahead and begin by looking at how we can solve a system by graphing. Now there's going to be three different methods that we're going to be using to solve a system of linear equations. The first method is by graphing. The second method is going to be called the method of substitution. And the third method is going to be what we call elimination. Now each of these methods have their pros and cons. Let's talk about graphing for a minute. So the advantage to graphing is that it gives you a nice visual. We can see exactly where the lines intersect at. We can see in special situations where maybe they don't intersect at all, or maybe if they are both the same line and they intersect over an infinite amount of points. So the nice thing about graphing, it gives us that visual to see exactly what's happening, and for us to recognize too that our solution for the system is we're looking for both an x and a y. Unlike the previous lesson, or one of the previous lessons, we were solving equations, but there was just an x, and so we're just looking to see what x value would solve that equation. For this one, we're looking for both the x and the y, so your answer is going to be in the form of a coordinate, and that's really significant. So starting by graphing is going to give us that advantage of remembering that and recognizing that. Now there are some distinct disadvantages to graphing. For one, let's face it, not all equations are going to have nice little answers of being an integer where it intersects at a grid line. And plus, who wants to take the time to always have to graph? So there's some, like I said, some distinct disadvantages, but some advantages to graphing. So we're just going to look at this one example for graphing because we've spent a lot of time looking at graphing. Now, if you notice, both of these equations are in what we call standard form. They're not in slope-intercept form. Now, some books would have you rewrite this to get it in slope-intercept form. You could do that. There's nothing wrong with doing it that way. However, in my past, in my history with working with students, I see that a lot of mistakes happen in that process of rewriting the equation to get it in slope-intercept form. And so I'd like you to try to avoid making some of those mistakes. And so instead, what we're going to do is we're going to graph this by looking at the x and y intercepts. How do we do that? Well, the first thing we're going to do is, if you look at that first equation there, I have a blue dot next to it, so I'm going to graph this in blue. So if we wanted to find the x-intercepts, what I'm going to do is I would cover up the y value. Why would I do that? Well, because an x-intercept is where y is 0. So if y is 0, that 2y, that minus 2y would disappear. So if you just take your thumb or your pencil and cover up that minus 2y and just solve for x, we would get x equals negative 2. And then to find the y-intercept, we're going to cover up the x, and so we would just have just the y. Now you want to make sure you solve for y. So when I cover up the x, I would have negative 2y equals negative 2. And so when I divide by negative 2, I'd get a y-intercept of 1. And so you can see from the graph there, we have our x-intercept at negative 2 and our y-intercept at 1. And so we can graph that line. And then we would do the same thing with the next equation. So we would find the x-intercept and cover up the 2y. So I would get x equals negative 6. And then to find the y-intercept, I'd cover up the x, and I'd solve for y. Now when I solve for y, I'd take negative 6 divided by 2, and that would give me negative 3. So my y-intercept would be at negative 3. And again, you can see the graph there. I've already put those on there for you. So we want to connect those points. Now when you're connecting those points too, sometimes it's helpful to come up with some other points in between if you don't have a straight edge. Okay, so you could always use the slope of the line and see that to get from negative 6 to negative 3 on the y-axis there, we'd be going down 3 into the right 6. So negative 3, 6 reduces to negative 1/2. So that would have a slope of negative 1/2. So we could come up with some other points in between if you wanted to. But anyhow, those two lines intersect at that coordinate where x is negative 4, y is negative 1. So that would be your solution. So that's how you would solve a system by graphing. So again, the solution is where the lines intersect. And the solution is always going to be a coordinate. Okay, let's look at the next technique now. We've done so much with graphing, I'm not even going to have you do a graphing one on your own. I think you have enough experience with that. But now let's look at how we could do this with substitution. With substitution, there's going to be about 4 steps. The first step is we're going to isolate one of the variables for one of the equations. Isolate just means we're going to get it by itself. Okay, like when they put a prisoner in isolation, they put them by themselves. So we're going to pick one of the variables to isolate, to get by itself. So essentially I have 4 variables. I have 2 x's and 2 y's. So when I look at those, I recognize that in that first equation we have a y that does not have a coefficient. So to get the y by itself, all I have to do is add 3x to both sides. So for me, that's going to be the easiest one to use. So I'm going to solve for y by, like I said, adding 3x to both sides. So now I have the equation y equals 3x minus 2. Now recognize what an equation or what an equal sign is telling us. It's saying y is the same as 3x minus 2. So the second step is we're going to substitute. This is where we get the name substitution. We're going to substitute what the variable is equivalent to into the other equation. So again, we're saying y is the same as 3x minus 2. So I'm going to take that 3x minus 2 and I'm going to put it in for y in the other equation. So in that other equation, that y is going to disappear. So I'm just going to have negative 7x plus 5 times what y is. And y was a 3x minus 2. And so having that in parentheses is very important. If you don't have the parentheses around the 3x minus 2, you're going to make the mistake of only multiplying 5 times a 3x when it's 5 times everything that y is supposed to be. So the entire quantity, 3x minus 2. And then it equals 14. All right, so then the next step is we're just going to solve for the variable. So we're going to solve for x. So I'm going to distribute the 5 through to get 15x minus 10. I'm going to combine like terms. Negative 7x plus 15x would be 8x. And I could also add 10 to both sides to get 24. So when I divide both sides by 8, I would get x equals 3. Now the nice thing about graphing is, again, it gives us that visual to remember that our solutions are always going to be a coordinate. Sometimes when we're doing some of this work, we go through a long process and we forget our goal. We forget what we're working towards just because it's taken us so long to get there. And so we just assume that, oh, I'm done. My answer is x equals 2. Well, the problem is we're looking for a coordinate. So when I get my answer for x, I'm not done yet. There's a fourth step. That fourth step is we're going to use that answer that we just got, and we're going to go back and we can substitute it into either equation. Because remember, we're looking for a solution that works into both equations. We're looking for when x is 3 in both equations, what's y going to equal? So again, it does not matter which one we use. So I like to look for the one that's might be the simplest to use. So maybe that first one will be the easiest to use. So I'm going to take negative 3 times what x is, 3, so negative 3 times 3, plus y equals negative 2. Well, negative 3 times 3 is negative 9. And if I add 9 to both sides, I get y equals 7. So my answer is, when I put these together, I get my answer is the coordinate 3, 7. So that's how you do this with substitution. Now I might have gone through that kind of quickly. If you need to go back and pause the video and go back to that explanation, you can go ahead and do that. Otherwise, if you feel ready enough, why don't you guys go ahead and try this one on your own. Now if you notice, I have the steps there out for you, so you can follow those steps. If you didn't get those in your notes earlier, I would strongly recommend making sure to get those steps in your notes though. So go ahead and pause the video and hit play when you're ready to check to see if you've done this one correctly. All right, let's see how you did. So the first step, you're going to pick one of those equations to get the variable by itself. Which one did you choose? If it were me, I would choose that first one too. I would have chosen that first one and solve for x. And so if you do that, all you have to do is add 3y to both sides. Now, if your equation says 15 plus 3y, no big deal. It's going to be the same thing. 3y plus 15, 15 plus 3y, same thing. All right, so now what we're going to do is we're going to say, well, we're saying that x is the same as 3y plus 15. So in that other equation, we can replace x with 3y plus 15. So I would have negative 4 times that quantity, 3y plus 15, minus 3y equals 15. And then again, our next step would be to solve for the variable. So I would distribute the negative 4 through. That gives me negative 12y minus 60, minus 3y equals 15. A lot of negatives there. Okay, we're going to combine like terms. So I see I have a negative 12y and a negative 3y. Now they're on the same side of the equation. Please don't make the mistake of adding 3y. They're on the same side of the equation, so we just do what it says. We're going to take negative 12y minus 3y, which would be negative 15y. And then I would add 60 to both sides to get 75. And if I divide both sides by negative 15, I get y equals negative 5. Now again, that was a long process to get to that y is negative 15, but we're not done yet. We're looking for our answer in the form of a coordinate. So I need to figure out what's the x value. So I'm going to pick either equation. It doesn't matter which one you use. Which one did you use? Did you use the first one? If you did, it's going to look like mine. If you didn't use the first one, you're still going to get the same answer. All right, so we would take negative 3 times 5 and get positive 15. And if I subtract 15 from both sides, I get x equals 0. So that means my solution is the coordinate when x is 0, y is negative 5. please make sure you put those in the right order too. A common mistake that people will make is they just write down whatever answer they got first as your x, whatever answer you got secondly as your y. But if you notice, the first answer we got was the y value, and the second answer we got was the x value. So make sure you put those in the correct answer for your coordinate. All right, how'd you do? Did you get that one right? If you made a mistake, please make sure that you understand your mistake and fix that before moving on to this next example. Because this next example, we're going to look at another type of process that we could use, and that would be solving by elimination. Now, there's a couple ways that we could do these problems. Let's start with the most basic. Now, what we're going to start out with is if we have two variables with the same coefficient and opposite signs. If you have my notes, you might want to highlight or underline that sentence. We're looking for situations where we have the same coefficient, so the number attached to the variable, but with opposite signs, so one's plus, one's minus. And you can eliminate that variable by simply adding the two equations together. So look at the example that I have here. If you notice, the y's have a 3 in the first equation and a minus 3 in the second equation. So what I could do is I could just add these together, and we're going to eliminate the y's, because we'd get 3x plus 4x would be 7x. 3y take away 3y is 0. It's nothing. But negative 24 plus negative 25, when we add those together, we get negative 49. So the next step is we're going to solve for the variable. So if I divide both sides by 7, we get x equals negative 7. So we found our answer for x. Now from here, the rest of the process is just like the second part of the process for substitution. What we're going to do is we're going to use that answer that we just got in the previous step. We're going to plug it into either one of the equations. It does not matter which one we use. You get to pick whichever one you think it might be easiest. Maybe you think that first one would be a little easier. They both look to be just as difficult, so I don't think it really matters in this case. But we could replace x with negative 7. So we'd have 3 times negative 7, which would be negative 21, plus 3y equals negative 24. I could add 21 to both sides, and that would negative 24 plus 21 would be negative 3. And if I divide now by 3, I would get y is negative 1. So now we have our answer, negative 7, negative 1. Now you might think, man, this was a really easy process. Why don't we just always do this? That was really easy, just to add them together and make one of the variables disappear. Remember, it's not going to always be that simple. Okay? Like this next example, it says often it doesn't work as nice. And you don't have two variables with the same coefficient and opposite signs. If this is the case, you have to start by multiplying one or sometimes even both equations by number so we can get two variables with the same coefficient and opposite signs. Remember, with elimination, that is our goal, to have two variables with the same coefficient but with opposite signs. So let's look at what we have here. We have negative 2x minus 2y equals negative 2, and we have a negative 3x minus 10y equals negative 24. Now, if you wanted to get rid of the x's, we could. We'd have to multiply both equations by a number, though, because there's nothing I could... By the way, you want to avoid using decimals here. So there's no integer I could multiply negative 2 by to get a positive 3. I could multiply by 3, I suppose, and multiply the second equation by negative 2, so we'd have negative 6 and a positive 6. But let's look at, maybe it would be easier to get rid of the y's here. Can you think of a number I can multiply negative 2 by? So we would have the same coefficient as negative 10, but with an opposite sign. Are you thinking of negative 5? Hopefully you are. Because yeah, negative 5 times negative 2 would be a positive 10. So that is your first step. So the first step is we're going to multiply an equation by a number. And again, we just answered that question. What could we multiply the first equation by if we wanted to eliminate the y's? And that would be negative 5. So the second step is we're going to actually multiply both equations by that number. Now I'm going to go back a step. So look what's happening in the top equation. So I'm multiplying both sides by negative 5. Now make sure you multiply both sides by negative 5. Okay, not just the left side. Not even just the y. Multiply everything in that first equation, we're going to multiply by negative 5. So when you do that, we would get a positive 10x and a positive 10y equaling a positive 10 as that first equation. The second equation, we don't have to do anything to. We can just rewrite it as it is. Because then, our second step is going to be what our first step was in the previous example. We're just going to add these two together. When you add these two together, 10x plus negative 3x is going to be 7x. and the y's disappear because 10y minus 10y is nothing. And 10 take away 24 would be negative 14. And so now we just solve for x. So when we solve for x, we divide both sides by 7, and we get x equals negative 2. All right, so now we have our x value. So just like the previous examples, we need to figure out what our y value is by substituting that answer that we got in step 3, that x equals negative 2. We're going to substitute that into one of the equations. So it doesn't matter which one you use. So it looks like I use the first one here. So we're going to take negative 2 times our x value, which just so happens to also be negative 2, minus 2y equals negative 2. Boy, a lot of negative 2's there. All right, so now we're going to simplify that. So negative 2 times negative 2 would be a positive 4. Subtract 4 from both sides, and I would get negative 6 on the right. Divide both sides by negative 2, and we would get positive 3. So our solution, make sure you put these in the right order, is negative 2, positive 3. It's that coordinate. All right. You following me so far? Why don't you see if you can try one of these? Why don't you try this one on your own? So again, those 4 steps are given to you here. So you have those available to you. But why don't you guys use elimination? So you're going to have to multiply one of these equations by a number. So figure out which one we'd want to get rid of. By the way, if you look at the steps there, it says getting rid of the y's. We don't have to get rid of the y's. In fact, you might want to get rid of the x's in this one. So ignore that. That was just copied and pasted from the previous example. So anyhow, take the time, figure out if you can do this one on your own. So pause the video and hit play when you're ready to check to see if you've done it correctly. All right, were you successful? Did you get an answer? Let's see if you got the same as I got. Okay, so the first thing is, again, like I said earlier, I'm going to get rid of the x's in this case. So I'm going to multiply that the second equation by 5. Because the first equation already has negative 10, so I want to have the same coefficient but with an opposite sign. So I want that 2 to change to be a positive 10. So I'm just going to multiply both sides of the equation by 5. So we would get 10x plus 20y. Don't forget on the right side, 5 times 8 would be 40. And then the first equation would stay the same. Then when we add those together, just like we wanted, the x's will eliminate. The x's will cancel each other out. And negative 6y plus 20y would be 14y. Now the right there, 30 plus 40 would be 70. And if I divide both sides by 14, we'd get our answer for y, which would be 5. Then we plug that into either equation. So this time I put it in the second equation, working with a little bit smaller numbers there. So we'd have 2x plus 4 times 5, or 2x plus 20 equals 8. Subtract 20 from both sides, and I would get negative 12. And negative 12 divided by 2 is negative 6. So you get your coordinate of negative 6, positive 5. How did you do? Hopefully you got that one right. Now if you're struggling, please make sure you pause the video. Don't keep going. But I want you to make sure that you're figuring out, identifying where that mistake is and trying to correct that. Okay. So I want you guys to look at this next example. So sometimes we have some special cases. There's 2 different kinds of special cases we could have. The first of which is a situation where there's no solution. No solution? What would that look like? Let's start with graphing. So think about it for a second. If we're graphing 2 linear equations, what would 2 linear equations look like when we graph them and they don't intersect? What would those look like? Hopefully you're imagining parallel lines, because that would be the case. Okay, so if 2 lines are parallel when you graph them, there's no solution. Remember, the solution is where they intersect at. They don't intersect if they're parallel. Well, what's that going to look like if we're not graphing? What is that going to look like when we're using substitution? Well, the way that's going to look is when we substitute in the expression and the variable cancels out and you're left with a false statement, like 3 equals 7 is a false statement, 3 doesn't equal 7, that's a situation where there would be no solution. Okay, so when we go to this substitution piece, when you substitute it in, and if you substitute it in, if the variable disappears and we're left with a false statement, there's no solution. What does that look like then if we're doing elimination? Well, with elimination, if we go to eliminate one variable and both variables cancel out and we're left with a false statement, then it's going to be no solution. Okay, so anytime we're left with a false statement, like 0 equals 4 or 3 equals 7, that means that it's a situation involving no solution. So we just say no solution. Okay, don't say 0, by the way. 0 is not correct. You would say no. You'd actually write the words no solution. Okay, so that's our first special case. Our second special case is having infinite solutions. Well, they don't just intersect at one spot, they intersect infinitely. Let's think about graphing. When graphing, can you think of a way we could graph two lines and they would always intersect? There's never a time they're not going to intersect? What would that look like? How would you describe those two lines? Now, if you're imagining two lines that are laying on top of each other, that's exactly right. Okay, so if you have two lines that are the same line, if they lay on top of each other when you graph them, we would say that's a situation involving infinite solutions. Well, what would that look like if we're using substitution? Well, remember, if we substituted a piece in and the variables canceled out and we were left with a false statement, there's no solution. Well, guess what? If you do the same thing, if you substitute a piece in and you go to simplify it and the variables cancel out again, but you're left with a true statement, like 7 equals 7, that means that it's infinite solutions. Okay, because you're left with a true statement. How would this look with using elimination? Remember, if you eliminate the variables, you're going to have 0 on one side. If that's the case, and if you have 0 on one side and 0 on the other, 0 equals 0 is another true statement. So that's another situation where you'd end up with infinite solutions. All right, let's look at some examples. So we could solve these using any method of our choice. Okay, so let's look at this first one. Maybe for this first one, I noticed that the y doesn't have a coefficient. So maybe that first one, we'll use a substitution method and see what happens. So I'm going to solve for that first y. I'm going to get that y by itself. So we're going to subtract 5x from both sides. So I have negative 5x minus 4. Or if you wrote negative 4 minus 5x, it's totally fine too. So then remember, we're going to substitute negative 5x minus 4 into the other equation. So instead of 15x plus 3y, it would be 15x plus 3 times that quantity, what y is the same as negative 5x minus 4, equals negative 7. And the next thing I would do then is I would distribute the 3 through. So when we distribute the 3 through, we would get negative 15x minus 12. Now if you notice, 15x minus 15x, that equals 0. The x's disappear. The x's are eliminated. So we're left with negative 12 equals negative 7. Now clearly negative 12 does not equal negative 7. So this would be a situation that would be no solution. Okay, so that's how that looks. That's how that special case would look. Let's look at the next one. Now the next one, if you wanted to, you could use a substitution method again by getting the x by itself. But just for the sake of doing something different, I'm going to use the elimination method this time. So I'm going to multiply that second equation by, let's say if I want to get rid of the x's, because I see that the first equation has a negative 3x, the second one is a positive x. So if I just multiply that second equation by 3, I'll get the same equation, or the same coefficient with opposite signs. So I'm going to do that. So then I would get negative 3x plus 12y equals negative 60. That would stay the same. But the second equation would be 3x minus 12y equals a positive 60. Don't forget to multiply the 20 by 3 as well. So now when I add these together, the variables disappear because both the x's cancel out, but also 12y minus 12y is also 0. So the left side is 0, the right side is 0. That's a true statement. So that means that we have infinite solutions there. So that's how it would look with your special cases. All right. I want you to try these two on your own. So why don't you guys go ahead and pause the video and hit play when you're ready to check to see if you've done these two correctly. But both of these involve some of those special cases. All right. How'd you do? Well, let's look at both of those. So that first one, you should have gotten infinite solutions. Okay, maybe you multiplied the first one by 2, and because I like elimination personally, I don't know, I've always found that would be a little bit easier. But let's say if you multiplied the first one by 2, well, you'd have 2x plus 12y equals 8. When you add those together, everything cancels out. With the second example, you should have gotten no solution. Let's say if you use elimination for that one as well. If you multiply the second equation by 2 as well there, you'd have positive 10x and a positive 12y equals 30. So don't forget, if you got infinite solutions for the second one, it's because you probably forgot to multiply the right side of the equation by 2 as well. But the right side there should be 30. So when you add those together, yes, we'd get negative 10x plus 10x is 0. Negative 12y plus 12y is also 0, so we'd get 0 on the left. But on the right side, negative 15 plus 30 is 15. It's not 0. So 0 equals 30 is a false statement. So that would be a situation involving no solutions. All right, so Hopefully now you can have a better understanding of how to do those different methods. In the next video, we're going to be learning how to solve a system of linear inequalities. And just to give you a heads up, it's a completely different process than what we've done. So please make sure before moving on to the next lesson that you understand and have done the assignment for this lesson with how to solve a system of linear equations using graphing, substitution, and elimination. So good luck then as you work on that assignment.